Hello, fellow decision scientists for operation management. This is the title of our class, in fact. Welcome to the class. Before we start working on the core content of this body of knowledge, I decided to first do a quick review on the meaning of decision science. What does it mean? It is very connected to the definition of mathematical model in the field we are tackling this course. Because as you noticed in the title of the course, it is Decision Science for Operations Management. So decision science could be for any area. And here in this course, we are doing it in the field of operations management, and our main tool, our main approach is mathematical modeling. We will discuss it in details in future, and you will learn it very well. This is gonna be fun. It is not one of those math courses that usually we don't feel good about. It's very nice because it's very practical. You will notice the logic behind many of the decision support systems around us, and every day we use those things. So you feel good about them, and usually, according to my previous experiences, students enjoy this course because on one hand they learn a lot, and also they can have a good time because it is something like solving a puzzle and things like that. Okay, at the first, the body of knowledge that involve quantitative approaches to decision making has three usual names: management science, operation research, and decision science. The name of this course that you have is decision science, but there is no difference between management science. Maybe you have noticed there are some journals in the market named management science. It is exactly the same things. Or operation research. Maybe some of you have had this title before while you were doing your bachelor. But the beginning of this body of knowledge, this science, is World War II. The reason was the complexity of the decision-making situation, problems. So human mind couldn't do it anymore. So that was the beginning. So they started to create a body of knowledge. They started to create a science to help them with the decision makings that were much more complicated and sophisticated than the previous cases. And they needed some sort of tools, they needed some sort of leverage to be able to solve those problems. And also with the very rapid rise in the power of computer, in fact, computer science. So the computers were able to do all those complexities in computational complexities. So that also contributed to the growth of this area. So it happened. So, but now you may ask yourself, okay, what kind of problems are those problems that human mind can do it, and we need to give them to computers to do them for us, or we need to seek help from this body of knowledge that we called decision science. In the next slides, in the next 3 slides, you are going to see a very simple example in this case that human mind really is incapable of doing it quickly. but we are going to do many examples together. This course is a practical course. It is a course like workshop. Now, hopefully, when we return to class and we could have in-person class together, so you will notice that it is absolutely like a workshop, and it is not lecture type, because you need to do it. It is like swimming. It is like bike riding. You need to do it to learn it. And but now, just as an example, okay, there is a corporation. You see, is a PAR Incorporated, is a small manufacturer of golf equipment and supplies, whose management has decided to move into the market for medium and high-priced golf bags. PAR Incorporated's distributor has agreed to buy all the golf bags that this company produces over the next 3 months. Each golf bag produced will require the following operations. Okay, cutting and dyeing, sewing and finishing, and inspecting. So there are 4 courses. And remember, we are not going to model it. We are not going to do anything on this. And here I'm just trying to give you a glimpse of that complexity that we are talking about. It's a very simple problem, but see, we cannot do it quickly on our own without help of these tools that we will learn. And it gives you this information, and it says that, okay, those 4 processes that we talked about take a specific amount of time. For example, for each bag, there are 2 bags, standard bag and deluxe bag, and each of them takes certain amount of time. For example, you see, for finishing a standard bag, it needs 1 hour, but finishing a deluxe bag, it needs 2/3 hours. And we have all the things, and also it tells you there are some limitations. For example, for the cutting and dyeing part, there are only 630 hours available, 600 hours available for sewing, and 708 hours for finishing, and like that. Each of those departments has a specific amount of time available. Okay, another thing that adds to the complexity of problem, it says that for each standard bag that you sell, you will get $10 profit, and for each deluxe bag, you get $9. Now you need to distribute all these resources that you have in a way that you maximize the profit. You see, you cannot solve it quickly. You cannot do it, even if you are very good with basic math, you cannot do it quickly. So in this situation, we need to ask help from this area of knowledge. That how many standard bags and how many deluxe bags we need to produce to maximize our profit. And we are going to discuss such a thing. And remember, it's a very simple question. There are examples that instead of 2 Prada standard and deluxe bags, there are 1,000 Prada, and you need to distribute all these resources among all of the things to get the maximized profit from them. I hope so far you have got a glimpse of what this course is about. In this slide, you see we have different kind of models. When you want to solve such a things, you need to model it. We have different models, iconic models, analog models, that we are not going to do anything in this semester with them. For this chapter, we are going to do a mathematical models. It means that we are going to create a mathematical model of this problem that we just discussed. And after that, we are going to solve that mathematical models and we get the results. That's the reason I'm telling you, you are going to have a fun time because all the problems are practical problems, and at the end of each session you would find yourself more capable of solving the problems in the world outside, especially if you are dealing with such problems at your work. And that's the reason I'm asking you to ask me at any time if you have any question, because this course is not a lecture type course. This course is practice type course, and you need to do it. And absolutely, I will usher you, I will supervise the process very closely, and I will post the announcement and will tell you what to do, how to do, to make the most out of this class. So another things that you learn in this slide is that we are going to do mathematical models. And when we create the mathematical model, okay, after that we solve it and we get the results. When you want to do a mathematical model, you need to define some parts of the model. Okay, one part is the objective function. Every mathematical model has an objective function. For example, in the previous problem that I described for you, the objective function was the profit of that company. That's the profit of the company that you want to maximize. We are going to discuss all these things in details in future, but objective function is the necessary part of each mathematical model. When you want to define a mathematical model, first of all, define the objective function. What is the objective function that you want? Objective function is maximizing the profit. Another things that you need to define is the constraint that you have. Okay, you want to maximize the profit, but what are the constraints that you have? Here we have constraints regarding the availability of times in each department. So we need to define them. Another things that we need to consider in mathematical models, there are some uncontrollable inputs that we cannot do anything. For example, if each standard bag in the finishing part take 1 hour, I cannot do anything about that. So these things are uncontrollable inputs, or we can call them parameters, or the fact that each standard bag is $10 profit, gives $10 profit, is uncontrollable inputs. So you need to check all these details with the mathematical model. What is the objective function? What is the constraint? What are the parameters that you have here? Another things are decision variables. Why you want to solve this mathematical model? What's the reason you develop this mathematical model and you want to solve it? Because you want to get some decisions. What are those decisions? Decisions are decision variables. Decision variables are since we want to discuss it in future, I don't want to ruin the educational goal of these examples, but no problem. What is decision variable? Why you define such a problem? Because you want to know how many standard bags you need to produce and how many deluxe bags you need to produce. So you need to define each of these things. Each one of these things is called decision variables. In the next presentation that is happening this session, you will see all these things. This is an example. This is an example of a mathematical model. It is not the mathematical model of the golf bag producer example, just is another mathematical model that you can see here. It is the objective function, maximizing something. It is the constraint, 5x is smaller than 40. That is the constraint, and 5, 10, 40 are uncontrollable parameters here. And just this is a very simple mathematical model. When you define your objective function, when you define your decision variables, when you define your constraint with help of all the uncontrollable parameters, okay, your mathematical model is ready. Thank you so much.